In this video, we're going to be taking a look at 3.1.3 basic inputs programming, and specifically we're going to look at part 3, which is going to be working with the potentiometer to help control some of our outputs. So in this step, we have already created part 2 in a previous video, and since I've already got part 2 ready to go, I'm going to go ahead and go to File, Save As. And since I've already got that saved, I'm going to go ahead and change this over to part 3. And then I'm going to go ahead and hit the Save button. What I can do from here, this keeps me from having to redo the motor and sensor setup and retyping a bunch of information. I can type in, instead of part 2, I can do part 3. And this one here is just called, so using the potentiometer. So I'm going to go ahead and put that in there. I can take out some of the pseudocode from part 2. Likewise, I can go ahead and take out the programming from part 2 as well. So now I'm ready to go to start part 3. So in part 3, they start off by giving us a sample code, which they want us to go ahead and document the pseudocode and also provide line-by-line comments. So I'm going to go ahead and copy this code. We'll bring it into Robot C. I'll get rid of some of the white space to condense down the amount of lines we have in the program. And here I can go through and start to take a look at some of the commands that are being used. So in the pseudocode, I can say turn green LED on, so I can see that happening there. I can say then, and in here they're using the until statement, until the potentiometer reads greater than 2048 for the reading. Then we're going to turn green LED off. We'll start the left motor at half speed. Wait for 3.5 seconds. Stop the left motor. So those are that would be what the pseudocode probably looked like when they wrote the program. So again, I'm going to go ahead and grab the pseudocode. I can go ahead and see, all right, here are line-by-line comments that we will put in. So I'll go ahead and do a couple backslashes, and then I like to just copy and paste, especially with some of these longer ones. We'll copy and paste the comments in. Now I'm going to go ahead and we'll go ahead and keep these a little bit closer. My little video here of the test bed will probably get in the way as we get down further down the template. But this is a real quick and easy way to go ahead and do that. So without having to do a lot of editing. And this will take care of some of the documentation of our program. So let's go ahead and compile and download the robot, and we'll see what kind of behaviors we get. So we're using the potentiometer, so make sure you know which one you have. The potentiometer is one of the ones. This is the encoder on top. This is the potentiometer. It may be beneficial while we run this program. Let's switch over in the debugger window to the sensors. So let's go ahead and let's make sure our potentiometer is reading all the way down to 0. That might be beneficial. We can see that down here in the debugger window, and we'll see what happens when we run this program. So I'm going to go ahead and say start. You're going to see the green LED turns on, and then you'll notice as I turn the potentiometer, it stays on until I'm going to hit close to 2048. So I'm going to wait till I get close, and then once I get past that, it'll turn that green LED off. It ran the left motor for 3.5 seconds and then stopped. So now if I ever start this program, like for example where it was on 4095, I hit start, it's going to automatically just skip the first 3 lines of code because it's already met the condition that the potentiometer's greater than 2048. So in order for this to properly run, I have to make sure my potentiometer, verify it's at the right setting, press start. You'll notice now it doesn't automatically start the motor. That green LED is on. I turn it past that direction, it's going to run the motor, and then now go ahead and stop after 3.5 seconds. So some of those things, the debugger windows are going to come in very handy for some of these other sensors, so that way you can verify some of the settings and things like that. Okay, so that's kind of really, we get a good handle on what that program is. Now they want us to modify the program. They want us to verify the potentiometer is a value less than 2048. We want to turn the green LED on until it is at a value greater than 2048, which we already have. They want us to turn off the green LED, and then they want us to turn on the left motor at half power until the potentiometer is at a value of less than 2048 and turn off the left motor. Okay, so when we go back into our program, we start to see, well, first off, let's go ahead and let's just grab these simple behaviors. I'll copy them and we'll bring them into our pseudocode in our template. Now I'm going to go ahead, I like to take out the letters because they tend to get kind of, if we leave them in there, they kind of get messed around with. So it says verify the potentiometer is at a value less than 2048. Turn on green LED. I'm going to go ahead and hit enter here and say until the potentiometer is at a greater value of 2048. And really this verify statement we really don't need in here. We just need to know that, one, when we start this off, that it's going to gotta be less than that. So we'll turn on the green LED, much like how we did in the example code. Turn off the green LED once it's greater than 2048, and then it says that we want to turn on the left motor at half power. I'm going to go ahead and hit enter. We'll go ahead and say until the potentiometer is at a value less than 2048, and then they want us to turn the left motor off. So that works pretty well. Now let's start to see and look in our code. So looking at our pseudocode, turn the green LED on until the potentiometer is greater than 2048, turn it off, and then we want to say, and it says, then we want to turn on till it's at half power, but instead of a wait statement, we're going to go ahead and, rather than the motor running for 3.5 seconds, we want to say until potentiometer, and either you can type this and you can find the shortcuts there. Either you can choose with the arrow keys, you can move up or down to choose which one you want, or the other option is, let me hit escape here, and I can go into natural language, the until section, and grab until the potentiometer is less than, and set that into the code until it's less than the position that we want, 2048, sensor port, potentiometer. Whenever the autofill pops in, I can go ahead and hit enter to set it in there, and then we want it to turn the motor off. So this right here, most of our code and our comments are going to stay the same, and I can just grab this pseudocode, copy, 2 slashes, paste, and that'll set in my code there below. Let me see if I can downsize this. There we go. That way we can see what that looks like. Okay, so now we have all of our comments, we've got our pseudocode, and it does our behaviors. So let's compile the program. Let's make sure I'm going to turn my potentiometer all the way back down to 0, and when I download the robot, I can verify that as what they said in the simple behavior that's in the activity. So if I check my potentiometer, it is reading at 0 by having it turned all the way. So now, alright, we're going to go ahead and get ready to run this program. So I've verified that my potentiometer is down here at 0. I'm going to go ahead and hit the start button. So you can see the green LED turns on. I'm going to go ahead and turn my potentiometer. I'm going to go slow. So then that way, once I get past 2048, the motor turns on, that LED turned off, and now it's going to continue to run. So I'm going to keep going up just a little higher. Then if I want it to go through and stop, I got to turn the potentiometer back down past 2048. It stops the motor and it stops our program. So this will, let me close our debug window here. This will finish out the program for activity 313 part 3, and we were able to see that we did follow the behaviors and we got the expected result from our test bed. check out activity 313 part 4 to start looking at how to use the optical shaft encoder to control some of our outputs.